In this video, I'm going to cover Unit 2 from the print reading textbook. So this unit covers lines and lettering. We're going to cover lettering first because it's the quickest to cover. Lettering is really simple in engineering drawings. It's always going to be a Gothic font. So this Gothic font, you'll see it in Microsoft Word called like Century Gothic. It's just a very simple font, okay? It's known as sans serif. Serif are those little squiggly things on fancy fonts. The font we use on drawings will omit those serifs and just be as simple as possible. Now, this font is pretty old. It was really developed because it's easy to do by hand. If you look at it, all of the letters are really geometric. So the C's are kind of like, a circle with just a little bit cut out of it, right? So it's really easy to draw by hand. It's really unmistakable. Say if you did a term paper or something, you did it in a Gothic font, it would really stick out at you. But it looks just at home on an engineering drawing, okay? Another thing, on engineering drawings, all of our lettering is gonna be in all caps with a few minor exceptions, okay? So the biggest exception are things like millimeters, which are going to be lowercase, some metric abbreviations. Abbreviations will sometimes be lowercase, but any sentences, everything in the title block, your name, title, all of that's just going to be in all caps all the time, okay? So in most modern CAD programs, this is just going to be the default font. You don't have to pick what font to use. That's just going to be it. Now, this only applies to engineering drawings and architectural drawings. They kind of just use whatever. So if you're doing plans for a house for somebody, a lot of times you'll see fancy fonts for the title and this and that. Engineering drawings don't do that. Always the simple Gothic font at all times. So that covers lettering. The biggest part of this unit is going to be our lines. So if you've seen a drawing before, it's just a representation of a real thing in 2 dimensions. We have to use the lines strategically to show the reader of the drawing exactly where things are. So there's a bunch of different kinds of lines to talk about, which I'm going to do in this video. The first thing, the lines come in 2 different thicknesses. They come in thick and thin. Now, the exact dimension doesn't really matter. Different CAD programs are going to produce them at slightly different thicknesses. As long as you can look at a piece of paper and see that there's thick lines and thin lines, you're good to go, right? You don't have to get out a micrometer and find out exactly how thick the thick lines are, how thin the thin lines are. Now, this isn't how it always was. Back when drawings were done by hand, there were 3 line thicknesses. You had thick, medium, and thin. Now this made sense in a drafting room where you have all these different lead pencils to make all these different kinds of lines and really make drawings like a work of art. The reason we don't do that anymore is because, if you have any experience with printers or copiers, you know they always screw it up. So you make a drawing super carefully in the computer, 3 different line weights, you go to copy it, and all the lines are the same weight. Right? So to avoid that, we just use 2 and just hope for the best when we go to print and copy, okay? The next thing that differentiates lines is whether it's a continuous line or the line is dashed. Now, there's a couple different kinds of dashed lines. They can be equal dashes, they can be long or short dashes. We're going to jump into the first category of lines, which are known as primary view lines. These are the most important because these are going to describe the shape description of whatever object we're trying to put on paper. So let's hop right into our primary view lines. These are going to be used to describe the shape of the part and what's going on with the general outline of the part. Now there's 3 kinds of primary view lines. We've got visible lines, hidden lines, and center lines. So let me show you how it works. I got a part right here, just a little block, right, with 2 holes in the top. We got a chamfer right here, and we got a step right here. So I'm just going to draw this on the board, just like you'd see it right here, right? So nice and simplified. We haven't talked about orthographic projection yet, so I'm not going to go into a bunch of other views. But what I want to show you is that the outline of the part, right, see, generally, basically the same, follows the lines. These are called visible lines, also called part outlines. These are always going to be thick lines. Okay, they're always going to be double the size of thin lines. The reason is that so you can easily tell what the actual part is. Now, when we dimension this part, there's going to start to be all kinds of lines popping up all over the place because we've got to have extension lines, dimension lines, notes, leaders, all sorts of stuff. We want to make sure the actual outline of the part is very clear. Now, the next thing, if you notice in the part here, we've got two holes going through the part. So without using another view, which is one technique to do it, how would we show in this view that there's holes going through the part? Well, you guessed it, hidden lines, right? So what we're going to do, a hidden line is going to be a thin line that has equal sized spaces, okay? So it's going to be, I'm going to use a different color to represent thin lines, okay? Because I can't control the thickness of a marker. All right, so we're going to say red is thin. We're just going to draw equally spaced thin lines where the holes would be if we could see through the part, right? If we had our X-ray goggles. Okay, so in that way, we can know there's holes going through the part without having to have any extra views. That's what a hidden line does. Remember, thin, equal spaces. The next is a center line. Center lines are used for all kinds of things. They're used to go through holes, and they're used to show the center of a rectangular part if it's symmetric. But for now, we're just going to use it to indicate the center of these holes. Why? Well, when you only have one view and you didn't know anything else about the part, when you see two hidden lines like this, you don't know whether that's going to be a cylinder going through the part or a square, right? It could just as easily be a square hole going through the part. The way we show that it's a round hole, like most holes, right, it's you at the center line. So a center line, again, thin, so I'm going to use red marker, and it's going to have alternating short and long dashes. Typically, there's going to be, in the center of it, one short dash and then two long dashes. Now, CAD programs don't always do this, so sometimes they'll be short, long, short, long. It's not a big deal, as long as you can tell it's different than a center line. So I'll do a short dash here, and then I'll do a long dash here, long dash here. I'll do the same over here, right? So it goes a little too far outside the part. Trim that up. So now, with just this one view, we know a bunch of information about the part. We know its general shape with our part outline. We know that it's got two holes going through the middle of the part, and we know they're holes because we have those center lines going through the hidden lines, okay? So that's all there is to the three kinds of visible lines. Now, these are the most important. They give us the shape description of the part. Let's chat about the next batch of lines we have. These are to do with the section view lines. So in order to talk about the section view lines, we got to talk about exactly what a section view is. A section view just cuts the part somewhere through the middle of the part to show you internal features. So in our example, we got our block. Say we wanted to cut the part right here so that we could see this hole with visible lines. Let me show you how it works. What we're going to do, and I'll use the light blue for all of our section view stuff. Now, the first thing we need is something called a cutting plane. This is going to tell us where we're going to cut the part. So a cutting plane will go right where that center line went, and it's going to have thick, either dashed lines, sometimes it's the center line, sometimes it's a phantom line. Everybody's a little different. In this case, just imagine it's a hidden line, but with thick lines, okay? We're gonna have two arrows that come off of that line. This shows us where we're cutting the part, okay? And you're gonna usually see labels. It'll be something like A, or B, okay? We're gonna see how that applies to the actual section view in a second, okay? So we're gonna imagine we're looking through the middle of the part going this way, okay? So we can see everything going that way. So let me show you the actual view. I'll go back to my dark blue marker. So I'm basically just gonna draw this part of the part, okay? So it's gonna be a little bit more of a square, right? So we're looking at this, now we're looking at this, okay? We're going to talk all about orthographic projection in a later unit. It's not the biggest deal right now, I just want to show you what a section view is. Now, since the part is cut, the sides of this hole are going to show up as visible lines, okay? Now, to make it less confusing and to indicate that this is a section, we got a special kind of line called a section line. These are going to be thin and usually at 45 degrees, and they're going to go through they're going to cover the portion of the part that got cut, the imaginary cutting plane. So now we got our section lines. And then the last thing we'll need is a center line, just like before, okay? Short, long, long. And then we got AA here. I'll put a label right there to let you know what section it is. So these arrows tell you which way you're looking. You're cutting the part right here, you're looking that way, okay? So when you see the part, you're seeing everything except all of this. Okay, I know it might be a little tricky to see this block and what's going on. Just imagine you're looking through the part. So the two kinds of section lines we've talked about so far, we've got our cutting plane line, okay, thick. We've got our section lines, which are thin, usually 45 degrees. The next is what's known as a broken out section, and we're going to use something called a short break line. Okay, so let's imagine we didn't even do this. There's another way to show the inside of a part with just one view, and that's with something called a broken out section. So what we're going to do, I'll go back to the light blue, a short break line is going to be thick and it's going to be kind of squiggly. It's meant to be freehand. Of course, on a computer, it's not really freehand, but it's like intentionally squiggly, so it looks like freehand, right? So what we're going to do, I'll get rid of these hidden lines real quick. I'm going to draw our short break line, the little squiggles. This is going to cut the part. Now we're going to assume it's going to cut through the middle of the part. There's no dimension to indicate it, but people, just go ahead and assume. Now, these hidden lines are going to turn in to visible lines, similar to the section view we did before. And then any of this empty space is going to become the sectioned part. So we're going to add our actual section lines, and now we can cap it off with our center line as before, okay? So what this allows us to do is see a section in one view without having to do a totally separate view. So three kinds of section lines: our cutting plane, our section lines, and our short break line all work together to show us what's inside of a part, okay? So next, we've got our dimensioning lines. So all we've been doing so far is giving the shape description of the part, showing the features. What drawings are really meant to do, especially detailed drawings, is to indicate how big things are, right? How the location of things, the size of things, the information you need to make a part or to inspect it. So we got three kinds of lines that are going to help us with that. We've got extension lines, dimension lines, and leaders. So the first is our dimension line. So say we want to show the overall width of this part. A dimension line is going to be thin. It's going to have two arrows pointing to the surfaces you're measuring, and in the middle, it's going to have the number, which is the size, the dimension. So I'll use red. So say this is 4 inches, Okay, I'm gonna fill in my arrowheads. That indicates this dimension of the part. Now, we got a problem. If we only had dimension lines, our part would get really messy really quickly, right? So we have a dimension here, so we needed one here, we need one for the hole. If we put them all inside of the part, we're gonna get really cluttered really quickly. The way we get around that is with what's known as an extension line. So I'm gonna use light blue for the extension line. We wanna get this dimension line out here in space. The way we do it, we're gonna start a little bit away from the part so there's a visible gap. We're gonna come down with a thin, solid line, and now we can move this dimension line in here. So we're still indicating the overall length, width of the part, but the dimension isn't in the part. So I'm just gonna redraw that dimension line. All right. So dimension line, extension lines, okay? With the dimension line, in the ASME style, we're always gonna break the dimension line to put the dimension in there, okay? If nothing else is going on, you'll usually center your dimension. If you got more than one dimension, then you'll have to move it left or right sometimes. For now, we're good, okay? So the next is what's known as a leader. So a leader is gonna point to a specific place on the part for some kind of dimension or instruction. So let's do a leader for this hole, right? So a leader, again, has an arrow. It's gonna have a line that comes off, a short little horizontal shoulder, and then our dimension. In this case, since it's a hole, we're gonna need a diameter symbol, and I'll just make up a dimension, okay? So that's our leader. Again, it's a thin line, it's continuous, but it does have this little horizontal shoulder. If nothing else is going on, you want your leader to be 45 degrees, okay? So leaders can be used for all sorts of stuff. So you could point a leader just to this side of the part, and you could have a note that says paint, right? All sorts of notes, chrome plate, paint, sandblast. That indicates that this entire surface of the part, so if we're looking at it, this surface would be painted, okay? So those are our three kinds of dimensioning lines. There's more to it than that. When we start talking about dimensioning and tolerancing, I'll go through all the rules, but those are generally how the lines actually work. So in this next section, let's talk about some of the odds and ends. We got a couple different lines. We've got our long break lines, we've got our phantom stitch and chain lines to talk about. The first is our long break line. This is used when you have long parts that don't have much going on that you can shorten. So let me give you an example. Say you're detailing a broomstick, right? So you're gonna put your broomstick on a piece of paper. When you shrink down the broomstick, right? So you got the head over here, right? And you got the handle. Because it's so long, the handle is essentially gonna have no width when you shrink it down to a sheet of paper. So it's gonna be really difficult to detail. And there's not much going on, mostly just the diameter, maybe a radius on the end. But in different parts, it might be a shaft for a tugboat or something you have to do this to. What we're gonna do is break this. So we're gonna cut out this whole part, right? We're gonna smush it together so we can make the whole thing bigger. So our broomstick would look more like this on the paper. Okay, so we've taken out a bunch of the length of that. The short break line is just a little squiggle. Now, the book says it's a straight with just a little angle on it. Every CAD program is different. I'll just call it a squiggle for now. It's going to be a thin line, and there'll be a space between the two halves of whatever you split, okay? What this allows you to do is go ahead and have an overall dimension that's gonna be true, right? So say the broom handle's 5 feet long, you're gonna put 5 feet right here, not what this actual distance is. So I'll put 60 inches. Normally, the dimension line will have a little squiggle in it to let you know it corresponds to your short or your long break line, okay? So that's a long break line. The next is what's known as a phantom line. Phantom lines are used for a couple things. The primary one is showing alternate positions of a part. So say you have a little doodad and you want to show that the little doodad can be right here or it could be right here. Right? The way we do that on one sheet of paper is we're going to use the phantom line, which is going to be thin. It's going to be two short dashes and then a long dash. So two shorts and a long. Remember, a center line is one short, long, phantom, two shorts, long, right? So I'll start off long, 1, 2 shorts, long, 2 shorts, long, 2 shorts, and just keep going around. And then same idea to show the holes, right? So we just showed part could be here, or it could be here with a phantom line. I think I mentioned before, a lot of companies use phantom lines for cutting planes. That's a valid technique as well, right? So the next is what's known as a stitch line. This is in the ASME standards. I really don't know why. I've never seen it on a drawing. It's to indicate, as it sounds like, where you would put stitches in, I guess, heavy canvas or some kind of, I don't know why you would ever put this on an engineering drawing. A stitch line is just short dashes. Okay, that's good trivia to know. And then the last is what's known as a chain line, and you will see chain lines, okay? So let's draw a part. So we got a cylinder. Say a portion of it needs to be shot peened, okay? We don't want to shot peen this whole round surface. We just want to shot peen some of it. The way we do that is with a chain line. So a chain line uses short and long dashes, just like a center line, except they're thick, whereas a center line is thin. It's going to be a small distance away from the part, basically just a visible gap. So I'll start long, short, long, short, long, okay? Normally, this would have a dimension attached to it. So I'm gonna do my extension lines and I'll say 2 inches. And then we'll use a leader and a note, right? It indicates to shot peen there. So since this is a cylindrical part, you would shot peen all around, but that's, you know, it's a surface of revolution. So as long as you have it right here, that's understood that you mean all around the part, but only up to here. This portion of the part shouldn't be touched, okay? So that's our chain line. So that's it for line types. You know, there's a good handful. We'll get more into it when we do orthographic projection and dimensioning and tolerancing and get to actually use some of this stuff more. But that's about it. So I hope you enjoyed the video.